Today in this lecture we will study the physical quantities. The physical quantities can be classified into two quantities. Number one, vectors and scalar. A vector quantity is any quantity that has both magnitude and direction. यानी कि एक ऐसी quantity जिसमें हम magnitude भी बता सकें और उसकी direction भी बता सकें कि वो किस तरफ को move कर रही है, उसकी क्या direction है. ठीक है, that quantity is called vector quantity. For example, velocity, acceleration, force and momentum. In all these examples you can see that every quantity has a magnitude as well as its direction. A scalar quantity is any quantity that has magnitude only while its direction is not taken into account. A quantity which is only specified with its magnitude, that quantity is called scalar quantity. For example, speed, pressure, temperature, energy. All these quantities has only the magnitude. They don't defines the direction. So these quantities are called scalar quantities. We have an example of a scalar quantity. As you can see that the temperature is a physical quantity that has only the magnitude. As it is shown on the temperature on the thermometer that the temperature is 36.8 degrees Celsius. So it shows only the magnitude. It does not show the direction. So it is the physical quantity which has only the magnitude, so it is called a scalar quantity. We have another example for scalar quantity like time. It is a physical quantity that has only the magnitude, as you can see in the figure or use in daily life too. So another example of a vector quantity is the position of California from North California is 3600 kilometer in west. So 3600 shows the magnitude, and what will be its direction? It is moving. Its position is in the west, and which give you the direction. Similarly, we have another example in which you can see that if you are moving from USA to China, then the magnitude is of 11,600 kilometer and it is in the east direction. So displacement is a vector quantity which has magnitude as well as direction. How we represent a vector symbolically and graphically. अगर आप चेक करेंगे, अगर आपके पास एक पॉइंट है A and it inclined and move towards a point B with some inclination theta, so theta actually represents its direction and the AB, the line segment, give its magnitude कि A से B तक जाने के लिए उसने कितना distance cover किया है वो उसका magnitude show करेगा, और A ने कितना rotate किया है B की तरफ जाने के लिए वो उसकी direction show करेगा. So हमारे पास A जो होगा वो tail होगी, that is the starting point, and B represent the head. Why it is called the head or the terminal? Because A is moving towards B. It gives the direction कि A B की तरफ जा रहा है, इसलिए जो arrowhead है वो B के ऊपर आएगा. So symbolically it is represented as AB with an arrowhead. These are also represented by a single capital letter with an arrow above it. Now, अब ये अगर आप चेक करें, these all are vectors. Upward direction में है, some are in the downward direction, some are in opposite direction, some are in tilted direction. तो आपके पास ये different directions of vector है, जिसके अंदर हम उनको जो abbreviate करते हैं vector को कैपिटल लेटर के साइन से एब्रीवेट करते हैं और हम कुछ को स्मॉल लेटर से भी रिप्रेजेंट करते हैं. These are called the representation of the vectors. So they are also represented by a single capital letter with an arrow above it, as you can see that capital A vector, capital B vector, capital P vector. Some vector quantities are represented by their respective symbols with an arrow above it. Like position vector can be represented by small r, velocity vector can be represented by small v, and the force vector can be represented by the capital letter F having an arrow above it. These all are representation of vectors in various cases. Next topic is type of vectors, and the first and common type of vector is parallel vector. Two vectors are said to be parallel vectors if they have the same direction. As you can see in the figure, the vector A and B are in the same direction. They are in the upward direction. But their magnitude, if you can see in the figure, their magnitude is not same. The vector A is little bit bigger or larger than the vector B, whereas in the second figure, the vector P and Q are in the same direction also. They are in the downward direction, but they are also not have the same magnitude. So the parallel vectors are those vectors which are having same direction, but we are not concerning about their magnitudes. Okay, the next type of vector we have is the equal vectors. Two vectors are said to be equal if they have the same magnitudes. Now you can see that in the figure that the two vectors A and B are parallel and they have the same magnitude. You can see that these vectors are parallel also. In the second figure, you can see that P and Q are in the downward direction. They are parallel, but they are at the same time equal vectors. Why they are equal vectors? Because both have the same magnitude. A and B, both vectors have the same magnitudes. P and Q also have the same magnitudes, and both are in the same direction. So the vectors, two parallel vectors are said to be equal vectors if they have the same magnitude. So for the equal vectors, we require the two conditions. Number one, they must be parallel and they must have the same magnitude. The next type is antiparallel vectors. Two vectors are said to be antiparallel vectors if they are in opposite direction. Now you can see that these vectors are not parallel vectors, as the two vectors in figure number 1, AB, are not in the same direction. Similarly, in the other figure, P and Q are also not in the figure, and also they don't have the same magnitude. So in anti-parallel vectors are those vectors which are actually not parallel, right? And the vectors which are not parallel means they are in the opposite direction. Like the vector A is moving upward and the vector B is moving downward. Similarly, in figure 2, the vector P is in downward direction, whereas the vector Q is in upward direction. Next type of vector is negative vectors. Two antiparallel vectors are to be negative vectors if they have the same magnitude. If you can see that, what is the main condition for the antiparallel vectors? The vectors must not be parallel. So if you see in the figure number 1, the vector A and B are in the opposite direction. That represent they are not parallel, they are anti-parallel, but at the same time they have the same magnitude. So it defines the definition of negative vectors. Vector A and B having same magnitude but are opposite in direction. Similarly, in the second example, the vector P and Q have opposite direction but have the same magnitude. So the vector, why the negative sign is here? because the vector P is moving downward and the vector Q is moving upward. That shows that they have the same magnitude, and the negative sign shows that they have the opposite direction. If one is moving in the upward direction, then the other is moving in the downward direction, vice versa. Next type of vector is collinear vectors. Two vectors are said to be collinear vectors if they act along a same line. If you can see that in the figure, that vector A and P are in the same line. These two vectors lie in the same line. Similarly, in the other example, the vector P is followed by the vector Q. So, such cases in which the vectors act along the same line are called collinear vector. Coplanar vectors. Three or more vectors are said to be coplanar vectors if they lie in the same plane. If you consider a xy plane, and you have more than two vectors like A, B, C, and these three vectors all lie in the same plane, and that plane is xy plane, so these vectors are said to be coplanar vectors. If any four vectors A, B, C, D lie in YZ plane, not in different plane, should lie in the same plane, then that four vectors are said to be coplanar vectors. As you can see in the figure, the box show that they are in the same plane, and we in the vectors A, B, C, D, these four vectors are enclosed in a box which is actually representing a plane, and which is common plane for all these four vectors. Now, the next kind of vector is non-coplanar vectors. Three or more vectors are said to be non-coplanar vectors if they are distributed in space. Non-coplanar vectors are those vectors which are actually not coplanar vectors. That means they don't share the same plane, right? Like in the coplanar vectors, all the vectors lie in the same plane. They are sharing one plane. So for the non-coplanar vectors, that uh, shows that these are non-coplanar vectors, so they are not sharing the same plane. As you can see in the figure, the vector A, B, C are in the different planes. Next vector is actually a zero vector. Every vector which can be defined has a magnitude and a direction. So a specific vector which has a length 0 is called a zero vector. That means it has a magnitude 0 equal to 0, and a zero vector has an undefined direction. It can be defined in any convenient direction in which you require. Required, actually it does not has a direction. We define a zero vector is a vector with no length. The zero vector is not pointing in any particular direction, so it has an undefined direction. We denote the zero vector with a boldface 0, or if we cannot do boldface with an arrow, it behaves 0 with an arrowhead. It behaves essentially like the number 0. If we add 0 to any vector A, we get the vector A back again unchanged. Like if we add any real number A, like 5, or added 0 in it, then the resulted answer will be 5, right? Similarly, zero vector behaves in the same way. In the next topic, we will define the vector addition by using a geometrical method. If you are having two vectors A and B, and if you want to add the vector A into B, then we will use the method of head to tail rule, right? As you can see in the figure, the vector A the head of the vector A is joined with the tail of the vector V, and we got the resultant vector A plus V, which is actually equivalent to the vector C. So it can also be easily understood by considering this example. If we are moving from Egypt to Yemen, that is, if you can say it is a vector A, and from Yemen to Iran you can say a vector B to it, then the distance, the resultant vector will be C, which is from Egypt to Iran. So in the previous slide we have discussed how we can add the vectors. Vectors can be added by using the head to tail rule method, or it is called triangular law. So there are some properties relevant to addition in vectors. Like two vectors can be, just like in real numbers, that two numbers can be added and they hold the commutative property. Similarly, the vectors also hold the commutative property if A plus B equal to B plus A. And obviously, now we have another property, that is the associative property. In this property we have three vectors A, B and C. So adding these three vectors we will get another resultant vector, which is denoted by D vector. Associative property is that property that A plus B whole bracket plus C equals to A plus bracket B plus C bracket close. So in as you can see in the figure 1, the left hand side of the distributive law, which is that if A and B are added, then the resultant will be A plus B, which is represented by the dotted line. If we have another vector C vector, then A plus B, the resultant of A plus B is added into the third vector, and in correspond addition we got another fourth vector, which is the vector D, by using the head to tail rule. Similarly, in the second figure you can see the right hand side of the distributive law. So it holds the resultant vector. In both cases we have the D vector. Now we have the third property operation in the vector will be the subtraction of vectors, like we do in addition. अगर हमारे पास दो वेक्टर्स होते थे और हम उनको ऐड करते थे by using the method of head to tail rule, as you can see in the figure number 1. Similarly, अब हमने क्या करना है, सब्ट्रैक्शन करनी है वेक्टर्स की. अगर आप चेक करो एडिशन में क्या होता है, a प्लस b वेक्टर्स की एडिशन, और सब्ट्रैक्शन का मतलब है कि a माइनस b, यानी कि एडिशन का ऑपोजिट रिएक्शन है हमारे पास सब्ट्रैक्शन. ठीक है, ऑपोजिट ऑपरेशन है. तो इट मीन्स कि अगर ए हमारा जिस डायरेक्शन में है वो इट रिमेन्स इन द सेम डायरेक्शन, बट बी विल मूव इन द ऑपोजिट डायरेक्शन. एज यू कैन सी इन द सेकेंड फिगर, बी को जो डॉटेड लाइन से शो किया गया है वो माइनस बी के साथ शो किया गया है. देन द रिजल्टेंट वेक्टर विल बी ए माइनस बी. सो the subtraction of b from a is defined as the addition of vector minus b to the vector a. This is actually the subtraction of vectors.